Hello dear students. Again myself Pranali. I welcome to all in our course database management system, that is DBMS. Okay. So let's start. In last lecture we see that there are some data models named as relational data models, entity relations data model, object relational data model, and semi-structured data model, right? So one of the among of these all data models, there is one name, that is entity relationship model. So we from today's lecture we discuss entity relationship model in 2 or 3 videos. So where entity relationship model is used, dear student, in an introductory part we see that there is a phase of design phase, database design phase, right? So the initial phase of database design is to be characterized fully the data needs of the prospective database user. Suppose you want to design a database for your college. That time you must first find some real world entities, that is object, right? Relationship among them, the type of data you want to store in a particular entity. All this information is the first design phase of any database, right? So the next designer chooses a data model. After designer chooses one data model, and by applying the concept of chosen data model, translate these requirements into conceptual schemas of the database. We already covered the conceptual schemas for the database. There is only one conceptual schema for one database, right? In a conceptual schemas, all entities, relationship among all the entities are discovered. So this is a known as design phase for our database, right? A fully developed conceptual schemas also indicate the functional requirement of the enterprises. In a specification of the functional requirement, user describe which kind of operations or transaction that will be performed on the data for that database. So this is termed as design phase of the database. Now dear student, the process of moving an abstract data model to the implementation of database proceed a two final design phases. Suppose you are a abstract viewer for your data, right? So for abstract view to the original database design process, there are two steps: logical design and physical design. Okay, so logical design is depend upon we find a good collection of relational schemas. First, you draw a entity relationship diagrams. That means you find out which type of design you needed for your database. You find out the entities, you find out the relation between the data, tables, all are comes under the entity relationship diagrams. Next is a decision making, that is computer science decision. What relation schema should we have and how should attribute we distribute among the various relation schemas? Okay, after all we find out the layout for your database till now. Okay, after that there is a good collection of relational schemas. Finding a good collection of relational schemas is needed, means remove the redundancy. All your data should be a consistent. All for all this purpose there is a normalization concept is there. So for a database design we use entity relationship diagrams and normalization concept. So dear student, again I repeat, the entity relationship model allows a specification of enterprise schemas which represent the logical structure of your database. Nowadays, the database is related to the real world, right? So, real world applications that time represent the relationship between the different element of the database become the difficult. So ER model, that is one of the data model, simplify this task. It is nothing but the design technique for the database. It is a graphical technique which helps to understand, organize the complex data which should not depend upon the actual database implementation. So the real world object can easily map with the entity relationship model. Entity relation, that is ER model, is a graphical representation of the database system is generated. Diagrams are used in this model, and this diagrams is known as entity relationship diagrams, ERD. So dear student, for a entity relationship model, it is a graphical representation of your database, that is logical database design phase. So dear student, for the database design approach, there are two approaches. First is entity relationship model, second is a normalization theory. Okay, so first is entity relationship model. This model is a collection of entities and relationship. Now in this lecture, we cover the basic terminology related to the entity relationship model. First is entity, second is entity set, and third is a relation, then mapping coordinates. All are covered in this lecture. So let's start. So first model, this entity relationship model is a graphical representation of your logical or logical structure for database design. Then now in this first term is terminology is entity. So what is entity? A thing or object in the enterprise that is distinguishable from another object is known as entity. Let's take an example. Suppose you want to create a database for university. That time a student information, student, teacher, courses applied, all these are the separate entities for a one database. Then so describe a set of attribute. One entity describe a multiple set of attributes. So suppose student is a one entity. In that student entity, student ID, name, marks are the attribute of that student. Again I repeat, suppose I want to create a one entity name as student. I having a 100 record of student in that student entity. For every student, it having student ID, student name and marks. So these three, student ID, name and marks, are having a different value for 100 students or 100 entries. So these three values are known as attributes for the student entity. Student ID, student name and marks are three attributes of the student entities. Okay, so two terms we clear here, entity and attributes. Now relationship. There are an association among the several entity. We see in this video what is relation and types of relation. Next is, so again in a recap, entity relationship model represent the diagrammatically entity relationship diagram to describe the logical database design. Now second is normalization theory. This is also one design approach. In that we formalize that design are bad and test for them. So redundancy or another issues are test and check, clarify in a normalization theory. So for we are concerned for this video of the topic entity relationship model only. Normalization theory we cover in a second unit. So outlines for the ER model, dear student. Now again the ER data mode was developed to facilitate the database design by allowing the specification of the enterprise schemas that represent the overall logical structure of the database. We already discussed there are two type of database design: logical database design, physical database design. So your ER diagrams are the enterprise schemas representation of the logical structure for the database. The ER model is a very useful in mapping the meanings and interaction of real world enterprises, because we use an entity here. An entity is a real world object. So it is mapping of the real world enterprises onto the conceptual schemas. There is only one conceptual schema for one database. So we map real world entity into conceptual schemas. Because of this usefulness, many database design tools draw a concept from the ER model. Okay. So before creating any database, this is the first step to draw a ER model for any database. So ER model having three basic concepts: entity set, relationship set and attribute set. In this video, we cover all these 3 points in a detail. So ER model also an associated diagrammatically representation of the ER diagrams, which can express the overall logical structure of the database graphically. Done. So in a ER model, there are multiple ER diagram for the database to represent the logical structure of your database. So first, entity set. So dear student, first is an entity. We already covered entity is an object that exists and it is a distinguishable from the other object. Dear students, entity is nothing but a thing having its own property. Specific person, company, event, plant having its own property. This property helps to differentiate the object from another object. Okay. So your entity is a thing that exists either physically or logically. Remember here, your entity is exist either physically or logically. Entity may be physical object such as house, car, or entity may be a logical object such as account, account number, account details. We store account number and all in account entity. So account is a logical entity, right? So or house sale or car services, these are the logical entity, but your house, car is your physical entity. So dear student, entity may be a physically exist or logically exist, but entity is having its own property and it is differentiate from the another object or another entity. Then next is entity set. Entity set is the set of entity which share the same property. Means in a company, employee is the entity set which is having the similar property like employee ID, employee name, salary. This is the entity set, that is set of all the person having the same properties with the different entities. Companies having the same property of the different company entities. So this is known as entity set. Done. So first entity, second entity set. Third is your attribute. An entity is represented by set of attribute, that is descriptive property possessed by all the member of the entity set. Suppose here let's take an example of instructor. In instructor, so dear student, consider here instructor is an entity having ID, name, street, city and salary are the attribute for the instructor. Now in my instructor entity, suppose there are 10 entries, that is 10 rows. Okay, 10 entries means for these 10 entries they must have ID, name, street, city and salary. This the value of this 5 is associated with all these 10 entries. So this is known as attribute for the instructor entity. Now a subset of the attribute from a primary key of the entity set. That is, what is primary key? It is known as uniquely identifier for each member of the set. Again I repeat, suppose you student is our entity. I want to create a database for your class. Now student is my one entity. In that student, you having the I having the 70 student list with me. So I create a student entity. There are 70 entry having the attribute roll number, name, right, division or branch or marks or marks. Suppose this 4 attributes is with me. Now roll number is my unique attribute for this student entity. Why? Because no one having the same roll number in the same class, right? So this roll number column is a primary key or primary attribute among the all four attributes. So this is known as primary key, that is uniquely identify each member of the set. Using roll number attribute, I uniquely identify all the 70 students. Right? Suppose if I take a name as a unique attribute, that time same name, two or more student having same name, that time unique identification is not perfectly done. Therefore we chooses such attribute to identify each element of the set uniquely, is name as primary key for that entity. Done. Next, this is the again another example. Suppose entity set. Entity set means a collection of multiple entities. Here instructor and student are the two entities. Instructor is one entity having the attribute instructor ID and instructor name. Student is one another entity having the student ID and student name as the attribute for the student entity. Now these two entities are comes under the same entity set because they are a human. So this is the one entity set, a person or a human, and this entity set, person or human, having two entities, instructor and student separately. Now next, relationship set. Now till now we are clear the concept of entity. There are different multiple entities for the same database. Now next concept is relationship. So dear student, there is a relationship associated among the several entities. Like suppose student entry relationship set instructor entity. Means what? Suppose there is two entity, one relation entity is also there to set a relationship between two entities. This is a mathematical relation among the two or n is a number of entities greater than 2 taken from the entity set. Suppose E1, E2 up to having En are the relational entities of E1 which is belonging to E1 entity. Then this is the mathematical representation of relationship. How this is happen, we will see with the example. So dear student, this is a relationship for the relationship set advisor. So there is one advisor set. Advisor is one relationship set, and this is the advisor relationship between instructor entity and student entity. Means this is the creek having instructor ID 76766. This instructor is an advisor for the student Tanaka. Okay, so this cards is an instructor. Cards instructor is an advisor for the Shankar student. In this way, we are form a relationship between the two different entities. So this advisor is a relationship entity between instructor entity and student entity. Now see here. From this example, you clearly understood what is the relationship entity. So first, an attribute can also associated with a relationship set. For instance, advisor relationship set between entity set instructors and student may have its own attribute. Suppose let's take one example. This is instructor is a one entity, student is another entity. Now listen carefully. This is the advisor relationship between instructor and student. Now advisor also may have its own attribute. Consider for instructor entity there are two attributes, instructor ID and instructor name. For student entity there are two attributes, student ID and student name. Like way, this is advisor relationship, right? Relationship entity is advisor having one attribute date. How he represent using ER diagrams? Let's see. Crick is the advisor for Tanaka from date 3 May 2008. Right? Katz is advisor for Shankar from date 10 June 2007. Like this way, your entity relationship sets also have its own, may also have its own attributes. Okay. Now, there are degree of relationship sets. Dear student, there are there are some types, degree of relationship set: unary relationship, binary relationship, ternary relationship, or quaternary relationship. So binary relationship is a very common example in your entity relationship diagram. In that involves two entity set. When, like in a last example, here there are only two entity relationship, two entities are there, instructor and student, and one relationship are there. So this type of known, this degree of this relationship set is, degree for this advisor relationship set is 2, because they connect with a two different entity. Such a type of relationship is known as binary relation. That means in binary relationship, it involves two entity set, or degree is 2. Most relationship set in a database system are binary, but whenever a relationship between more than two entity sets are rare, more relationships are binary. So but let's take an example. Student work on a research project under the guidance of instructor. You are having the seminar for this year, so you are one student, and student gets associated with a seminar guide. So this two entities, student and seminar guide, are the two entity, and the relationship among them is associated or form as a guide. As a guide is a relationship. So this two entities and one relationship known as binary relationship. Okay. So next, there is a degree of relationship: unary, binary, tertiary, or quaternary. We will see in the last recap of this video. Now, mapping cardinality for the concept. This is also very important concept. Express the number of entity to which another entity can be associated via relationship is known as mapping cardinality constraint. Most useful in describing the binary relationship set. Now, for dear student, in a binary relationship, there are four types of mapping cardinality constraint: one to one, one to many to one, many to many. How? Let's see. Let's take one example. Some element in a first is one to one. So dear student, an entity in a here entity in a is associated with at most one entity in a B. See here, at most one entity in a B is termed as one to one relation. Okay. Now in a second case, one to many. In a one to many, an entity in A associated with any number of entities in a B. Any number means 0 or more. This is termed as one to many. Now next is many to one. Next is many to one. This is many to one. An entity in A is associated at most one entity in a B. An entity in a B, however, can be associated with any number of entities in A. Many to one. Again I repeat, an entity in A means this entity in A, A1, A2, A3, A4 and A5, associated with at most one entity. See here, every entity is associated, at most one entity is associated with a B entity set, and with B, however, can be associated with any number 0 or more. See here, many to one. Now This is many to many. In many to many, an entity in A associated with any number 0 or more of entity in a B, and entity in a B associated with any number 0 or more. So dear student, next topic is complex attribute. So in a complex attribute, there are some attributes type: simple, composite, single value, multi-value and derived attribute. First is simple and composite. In a simple attribute, dear student, remember that your simple attribute cannot be divided further. Okay, let's take one example. Suppose you having the student class, student entity, and there is a student age attribute. So this student age attribute cannot be divided further. So this is termed as simple attribute. Composite attribute is a opposite case of simple attribute. In a composite attribute, you can divide your composite attribute into subparts. Suppose student name is your attribute. This is composite attribute. How? Because you can divide your student name into first name, middle name and last name. So simple and composite attribute are defining on the divide or not. So simple attribute you cannot divide further, like example student age, and composite attribute you can divide a composite attribute further process. So student name is your composite attribute. You can divide a student name into first name, middle name or last name. Now next is single value or multi value. Single value attribute having only one value with them. Suppose name of the student or age of the student, or single value is associated with them, but multi value is for a single attribute. It may be possible it is having a multiple value. You having two phone numbers with you, that is your there are two numbers for one student, it is possible. Yes, so phone number is attribute term as multi-value attribute. Now last topic is derived attributes. So dear student, can be compounded from another attribute. So age is a one attribute can be calculated from the date of birth. So age is your derived attribute. So the attribute which can be computed using another attribute is known as derived attribute. Here age, you can calculate your age using date of birth. So age is your derived attribute. Now dear student, see here, name is your composite attribute because you can further divide first name, middle name and last name. Next, now we take a small recap of this all topics in detail. Entity. So dear student, there are entity means real thing or object, real word thing or object. So there are two type of entity, strong entity and weak entity. So dear student, strong entity and weak entity. In a strong entity having its own key element, but weak entity does not have its own key element. How? We take an example, parents and child. If parent and child are the two entity, parents it's having its own key entity and your child entity is depend upon the parent entity. So here parent entity is a strong entity and child entity is a weak entity. Next is entity set. We already covered that if the similar type of entities are grouped together to form an entity set. Now next is attribute. There are single value attribute, multi value attribute, simple attribute, composite attribute and derived attribute. We already covered this attribute point. Now relationship. Relationship, there are degree of relationship, unary relationship, binary relationship, ternary relationship and quaternary relationship. So dear student, this is the only one point remaining to for understanding. I take multiple example of each type of relationship. First is unary relationship. We already covered the definition of unary relationship. If only one entity is associated in a relationship, that time it is termed as unary relationship. Suppose your mother is someone's wife, means a woman Woman is a person. A woman may be a someone's mother. So a person is in a relation with person. It's termed as unary relationship. Person, woman is in a relation with someone's mother. So mother is also same woman. So this type of relationship is shown using in a unary relationship. Next is your binary relationship. So let's take an example. This is a binary relationship, always happen in a ER diagrams. You find out in every example there is a binary relationships. So teacher and student, suppose these two are the entity, and entity always shows in a rectangle, and relationship is denoted by diamond shape. We will cover in a next video the how to draw a ER diagrams. That time I show you all the notation for the entities, relationship, attributes, all. Now consider here the concept only binary relationship. These are the two entities, teacher and student, and now this is the relationship. How teacher is related to the student? Yes, teacher teaches student. So teaches is the relationship for the teacher and student, and here is a two entity. Therefore, this relationship is termed as binary relationship. Now, next is ternary relationship. So, dear student, this diagram shows the ternary relationship. These are the three entities associated with the relation in a relationship. So, person, teacher, student. So, person maybe is a teacher or maybe is a student. So this is the example for ternary relationship. We are moving toward the last topic, quaternary relationship. So dear student, this is quaternary relationship example. Employee, it may be a teaching staff, faculty, non-teaching faculty, or management faculty. So this is a relation between these four entities. So this is termed as quaternary entity. So dear student, this is all about entity relationship model and the basic terminology used in an entity relationship model. In this video, we cover entity, entity set, mapping cardinality, and the various type of relationship. Now, in the next video, we are moving toward the keys, different type of keys, and how to draw a ER diagram to design a database, logical design of database. So for today we stop here, and I again thank you all for your patience listening.